Okay, so question 5. A solid cuboid is made from centimeter cubes. So we're saying centimeter cubes, and these are some centimeter squares. The plan view, front elevation, and the side elevation are shown. So that's the plan view, front elevation, and side elevation. How many centimeter cubes were used to make the cuboid? So if it's asking me how many centimeter cubes were used, it's really asking me for the volume in centimeter cubed. So here we might have expected that there's going to be some bold lines here, okay, but I think what they mean is the plan view is all of this, okay, and the front elevation would be all of that, which is 3 by 4, and the side elevation would be all of this. Now if I'm looking for the volume, the front, I can say the front maybe goes along here, because I can see there's 4 squares there, so these 4 can go and line up over there. So it'll be 4 by 3, so it'll be 4 by 3, and then I need to see how long it is going backwards, and that's where I have to look at the side elevation. So it's going to be 4 by 3 and then by 6. Okay, so question 7 says 50 people took a test. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. 36 people did pass. Of these 36 people, 3 times as many predicted pass as predicted fail. Complete the frequency diagram, or complete the frequency tree. Now here, I'm just going to go back to this line. Of these 36 people, 3 times as many predicted pass as predicted fail. So there is some ratio about this 36. So 3 times as many predicted pass as predicted fail. So there's a 1 to 3 or 3 to 1 ratio. So 3 to 1 ratio that predicted pass as predicted fail for this 36 that did pass. Okay. Now back to the frequency tree. There's 50 people to start with. Prediction, pass and fail, we need to fill in. We've got 30 people predicted they would pass, so 30 can go there. This would be 20 because there's 50 people here. And then you might think, okay, from how can we have 30 people here and then 36 there? Well, that's not going to be possible. That's where we need to use this ratio. Okay, so there's 36 people, 3 times as many predicted pass as predicted fail. So 36, you need to sort of divide it in the ratio 3 to 1, okay, because that's what this is describing to us, and then fill in these numbers. Okay, so here you'll have 30, here you'll have 20. These two would add up to 30, and these two will add up to 20. That's one way you can check your answer. Okay, question 13, we have an identity here. For how many values of x is x times x plus 4 equal to x squared plus 4x? Circle your answer. Now, if the identity is correct, then it has to be all. Okay, so that's the definition of an identity, that for all values of x, this side is equal to that side. Okay, so question 14. Sophie sells birthday cards. She adds 30% profit to the cost price. So there might be something to do with a 1.3. She sells the cards for £2.34 each. So there was some cost price, and when you multiply it by 1.3, it gave £2.34. She wants to increase her profit to 40% of the cost price. How much should she sell each card for? Now I think this is a confusing question, because here it's telling you cost price, and then it's telling you she sells the cards for £2.34 each. So you might be thinking cost price and the selling price are actually synonymous, or they should be synonymous. But here I think what they mean is there is some cost price, and then you add the 30%, and then it becomes the selling price of £2.34. Then we have she wants to increase her profit to 40% of the cost price. How much should she sell each card for? Now we can say that £2.34 represents 130% of the cost price. So we can say 130% of the cost price is equal to £2.34. Now I can find 1% of the cost price by dividing this side by 130 and dividing this side by 130. Then I can times it by 140, because it needs to add 40% to the original cost price. So find 1% by dividing both sides by 130, then times it by 140 to find the new selling price. Question 15 is about place value and standard form. So we've got the 6 here, there's another 6 there, and there's another 6 there. We need a 6,000, we need 6 ones, and we need 6 tenths. So think about what A, B, and C can be to give us 6,000, 6 ones, and 6 tenths. Question 16. Work out the equation of the line that is parallel to the line y equals 5x take away 3, and it passes through -2, -4. Now, these questions, we need to think about having this in the form y equals mx plus c. Okay, so if I was to just write y equals mx plus c, we need to recognize this form as the coefficient of x gives us the gradient of that straight line, and the c represents where it crosses the y-axis or the y-intercept. If there's going to be a line that's parallel to this line, the gradient must be the same. So there's something that we already know about the equation of the line that I need to work out. So I know that it's going to be y equals 5x plus c. Okay, so it has to be, because they're telling us it needs to be parallel to the line y equals 5x take away 3, but it has to pass through -2, -4. Now, -2 represents the x value, -4 represents the corresponding y value for my equation. Now, if I was to substitute -2 into x and -4 into y, that's one of the solutions to this equation. So if I use those numbers, -2 here, -4 here, and rearrange this to find what c is, then I can find a new equation where I'm going to have y equals 5x plus some c here. Okay. Okay, question 19 says w is directly proportional to y. Okay, so that must mean there is some equation where w equals a number times y. Okay, here we've got w is inversely proportional to x squared. So then there must be another equation where we can say w equals, let's use k1 this time, times 1 over x squared. Okay, let's carry on. When y equals 4, w equals 14. Work out the value of w when y equals 9. So when y equals 4, w equals 14, we can use the first equation for that. So we can say 14 equals k times 4, and then rearrange to find what k is. And then I can rewrite this equation with a known k, and then substitute y equals 9 to find what w is. For 19b, when x equals 2, w equals 5, again we can substitute these values. So 5 will go here, and the equation that I have that relates w and x is this one. So we're going to have 5 substitute in for w, the 2 substitute into here for x, remember to square it, and then you can find this k1 that we have here. Then you can rewrite this equation, okay, with the known value here, and substitute x equals 10, okay, and then rearrange it, or you wouldn't have to rearrange it if you have it in this form. Find what w is. So for question 19c, which graph shows the relationship between y and x? Circle the correct letter. Now, we've only got two equations from the last two questions that we've done, 19a and 19b. Now, you would have found what k here is and what k1 here is, and you would have had equations where there isn't any k, but there's a number instead of the k. Okay. What you can do, you need to show a relationship between y and x. So you're going to have two equations, okay? One relating w and y, the other one with w and x squared here, but w and x. What you can do is you can solve them simultaneously and substitute one of these sides into the w and rearrange it to make y the subject, because that's what we normally have when we're looking at graphs of equations, and then think about which of these it will be. Okay, so if it's linear, it will be this one. You can already see that it probably won't be because there's an x squared here. If it's a quadratic, it will be this one. If it's some sort of exponential graph, it will be this one. And if it's some sort of reciprocal graph, it will be this one, okay? Because reciprocal graph, they will have some sort of asymptote. Here it shows that for x equals 0, there's no value, okay? There's no value because maybe you're dividing by 0, and then you would choose this one, okay? So think about what kind of function that you have. Make sure y is the subject of your equation, and then you'll be able to decide quite easily which of these it is. Okay, so question 20 says, this iterative process can be used to find approximate solutions to x cubed plus 5x take away 8 equals 0. Okay, so the iterative process is here. Now, let's think for a moment what this means. Approximate solutions to this equation. Now, if I find a solution to this equation, it means that there's an x value that I've found that works for this equation. And we're only going to get approximate solutions using this iterative process. So here it says start with a value of x, work out the value of this expression. Is your answer to 4 decimal places the same as your value of x? So the answer that you got here, if you were to take that to 4 decimal places, is that the same as your value for x that you actually substituted in here? If the answer is yes, this is an approximate solution to this equation. If the answer is no, use your answer to 4 decimal places. So use your answer from this to 4 decimal places as the next value of x and start again. Okay. 20a. Use this iterative process to find a solution to 4 decimal places of this equation. Start with the value of x equals 1. So you're going to substitute x equals 1 here. You're going to find a value. You're going to check if to 4 decimal places, is it the same as x equals 1? If the answer is no, then you would do it again. So you would take the answer here from 4 decimal places and you resubstitute it into here, okay? And then you check again, all right? And then you keep doing that until you get your answer to this to be the same as what you substituted when you check to 4 decimal places. And then that will be your answer here. X equals something here in 4 decimal places. Question 20b. By substituting your answer to part A, so you'll have some answer here, x equals something that is up to 4 decimal places. By substituting your answer to part A into this expression, x cubed plus 5x take away 8, comment on the accuracy of your solution to x cubed plus 5x take away 8 equals 0. So remember, this is an equation, and if I have the correct value of x and I substitute it in here, this side should equal to 0 because it's telling me that it's equal to 0. So if I was to substitute my value here into x there and into x there and I calculate this, does it get to 0? Now, because it's an approximate solution, it may not give us 0, but how close is it? That's the question. Question 21 says ABCD is a parallelogram. So ABCD is a parallelogram. CE equals CF. So CE equals CF. And we're asked to prove that y equals x. Now, I can see that there's a 2x here and a y here. Now, this is a geometry problem. Now, in geometry problems, you really need to think about what geometry is, what a parallelogram is. Well, a parallelogram is a quadrilateral. What's a quadrilateral? A quadrilateral has 4 corners. It has 4 straight lines. And if I was to mark a corner, for example, if I was to mark A, I know that angles around A add up to 360 because this is a point, angles around a point add up to 360. We should be looking for other clues like this as well. Here, in geometry problems, here you will get some information, and these are often clues. So if you haven't used this information to do something and you're stuck, think about how using some of this information will help. So I'll show you here how CE equals CF is going to help us. So CE equals CF. Well, that's telling me that this is an isosceles triangle, and if I know that that's an isosceles triangle, I can mark this angle and say that this is y, because the base angles in an isosceles triangle are going to be equal. Now, I've used this bit. Now, maybe I need to use this clue as well to help me somehow. And I can see that I've got a parallelogram here, and I'm going to use one of the rules for parallelograms. And I can see that if I was to take this corner, angles around that point add up to 360. If I was to take this corner, angles around that point add up to 360. But these don't really help me take x close to something in y. Now, I know that if I knew that this angle is 2x, because angles that are opposite each other in a parallelogram are equal. So if I was to mark this point here, the point C, and I also mark that this angle is 2x. Now I know that angles around C here will add up to 360. And also what I've done is I've taken x a little bit closer to where y is. Okay, and maybe I can have some sort of equation with x and y in it, and then that will help me get to a situation where I have y equals x. So angles around this point add up to 360. I can see that one of them is 2x. I have a right angle here. I have another right angle. I can actually find this angle here, the angle FCE, in terms of y. So I can say 180 take away 2y will give me this angle, because angles in a triangle add up to 180. Now once I know that, I can make an equation here and say 2x, add this 90, and add whatever I found here is equal to 360. So I can write that equation here, and that equation will have some x in it, some y in it, and then maybe I can rearrange it in some way where it will end up looking like y equals x. Question 22. The Venn diagram shows information about a coin collection. We know that there are 120 coins in the collection. T represents the coins from the 20th century, and we can see that's there. And B represents the British coins, which is here. A coin is chosen at random. It is British. Now, before actually I read the rest of it, I can see that there's 120 coins, and I know that if I was to add the x times x take away 15 to this x here, to x take away 2, and to the 32, that will equal to 120. Okay, so that will give me some equation. Okay, so I should know that if I carry on reading. So a coin is chosen at random. It is British. Work out the probability that it is from the 20th century. Now remember, the T is telling us the 20th century. Now it looks like it's asking for some value for the probability. I can't find it now because these are in a variable here, x. So x take away 2 there, x there. Now the probability that if it's British and we're asked what's the probability that it's from the 20th century, it's going to be x over whatever the total British is. So x over x plus x take away 2. Okay, so that's the probability that we're looking for. But that's in terms of x. We need to find what x is. Now, before I finish reading this question, I said that we can make an equation. And we can say that this part here, add this, and add that, is equal to 120. When you write that equation, you need to be able to solve that equation and then find the probability from that. So question 23, the speed time graph of a car's journey is shown. Okay, so it's here. Estimate the acceleration at 6 seconds. You must show your working. So the first thing we should notice is that this is not a distance time graph, it's a speed time graph. Okay, so this is how the speed is changing as time passes. Estimate the acceleration. Now, acceleration, this is speed and this is time. And acceleration is how speed changes for every unit of time. So at 6 seconds, so if I was to mark a point at 6, so at 6 seconds, how is the speed changing for every unit of time? Well, that is really the gradient. When we find the gradient of a curve or gradient of a line, it's how the y-axis or the values of the y-axis is changing for every unit of what's on the x-axis. Here we've got speed and time, so it'll be the gradient at this point. Now that's going to be quite difficult for us to work out because it's a curve here. So they have asked us to estimate, and what we can do is we can draw a tangent to the graph at that point. What that would mean is that around this point, the straight line that I draw will only touch the graph at one point. Now I'm going to try and do that freehand, but you would have to do that with a ruler. Once you've drawn a tangent, you'll see what we can do after that. So I'm going to try and draw a freehand tangent. So something like that. Once you've drawn your tangent, try and pick a corner that your tangent is going through. Like for example here, I can see that my line goes through one of the corners of the boxes. And try and find another one somewhere, and then find the gradient of the tangent. The gradient of the tangent should be the same as the gradient of the curve at that point. Okay, so and that will tell you what the acceleration is at 6 seconds. Now, question 23b is asking us to estimate the average speed of the car for the journey. You must show your working. So, average speed for the car for the journey. So, the graph is telling me what's happening in the whole journey, and I need to find the average speed. So, I need to find how far it's gone. I can see that it took 24 seconds, but I need to see how far it's gone and divide it by the time, which I already have, and that will help us find what the average speed is. Now, how do you find speed from a speed time graph? Now, I'm just going to use this part of the graph as an example. Here we can see that the car is traveling at constant speed, and it is 12 meters per second. 12 meters per second, that's from the 14th second all the way up to the 18th second. So for these 4 seconds, the car was traveling at 12 meters per second. So if I was to think about 12 times 4 because 18 take away 14 is 4, so 12 meters per second, and it did that for 4 seconds. So 12 times 4 would give me 48 meters. So what I'm actually doing is I'm finding the area of this part here. So for this section here, where the car was traveling at constant speed, I can see that it was going at 12 meters per second, and it did that for 4 seconds. So I'm going to do 4 times 12, which is the height. So 4 times 12, and that's the area of this section of the graph. It's telling me to estimate the average speed of the car for the journey, and this is the whole journey they're talking about. So I need to try and think about how am I going to find the area under this part here, under this part, and also under this part here. So under the whole graph, if I find the area, and it's telling me estimate, so it can't be accurate, estimate the area under this graph, and then divide it by what the time is, which is quite accurately given as 24 seconds. And that will give us the answer for question 23b. 23c now, evaluate your answer to part B. Tick a box, underestimate, exact, overestimate, and common. Okay, so here we need to think about, did we actually find the area, was our area an overestimate for the area or an underestimate for the area? We need to think about that. And we need to think about how distance divided by time, how that calculation affects whether or not it's going to be an underestimate or exact or overestimate. Okay, so question 24 says show that this large algebraic expression here simplifies to something much simpler, which is AW plus B over CW plus D, where A, B, C, and D are integers. Now, with these questions, try not to think about this part, okay, because it can look quite difficult. Like, how are you going to make that look like this? So try not to think about this part, but it's telling us it simplifies, okay, so it simplifies. So we think about this, and we think about how we're going to simplify this. Now, this is algebraic fractions, and we're multiplying them. There's another multiplication there. Now, this part we can immediately start saying that this is going to be over 1, okay, just to help us a little bit. And how do we simplify algebraic fractions when they're multiplying? Well, we're going to try and factorize or write the top part as a multiplication of factors, and the bottom part as well. See what cancels down. Okay, so there should be some common factors that cancel down, and then when you're getting closer to simplifying quite a bit, try and start thinking about how it's going to look like that. So we're going to factorize the bottom, factorize the top. What that will do for us is we'll have a multiplication at the top, multiplication at the bottom, and we'll have common factors that cancel down, and then start thinking about making it look like that.